Hi, this is Carlos Cousins, and the following problem is very, very difficult for a lot of people. And most people seem to believe that there is insufficient information to answer the question at first glance. However, because this is a linear function, something that you can hopefully intuit from the fact that the slope will remain the same across the line is that whether has a negative slope, a positive slope, whatever slope it is, the difference between the g of x value of g of 0 and g of 1 is going to have to be the exact same difference that you're going to have between g of 1 and g of 2. Otherwise, the rise over run, the slope, will not have been constant. So let's go ahead and assume that this dash here on the y-axis represents 16. This represents 1 on the x-axis. So we've got a point here, and that our line is going to have a positive slope. As you go up by whatever number and across by whatever number, you're going to be going down and across by the exact same number. So that the y value that you're going to have, the g of x value that you're going to have here, is going to be greater by the exact same distance as it will be smaller on this side. So basically we can plug in any value that we want for g of 0 and then figure out, or let's maintain the slope, figure out what g of 2 would be, and add them together to figure out what the answer is. So I'm going to say that g of 0 is going to be, let's say, 12. So 12 is going to be a difference of 4 away from 16. So that means that g of 2 is going to have to be 4 greater than 16. So g of 2 is going to have to be 20. So now we just have to add these two together and see what they equal. So 12 plus 20 gives you 32, and 32 is answer choice B here. Now you can plug in any number you want for g of 0, keep the difference, add it to what g of 2 would be, and you would always get 32 because the slope is constant. It's a pretty cool question, and you're likely to see it again. So this is how you did this one, and happy prepping.